Alright, so this is how to draw Lewis structures. The first step when you're drawing a Lewis structure is to count up the total number of valence electrons in the compound. As we go through the steps here, we'll use the selenite ion as an example of how to do this. Well, when you look at selenite, selenium comes with 6 valence electrons, as does each of the oxygens. So there's 6 times 3 is 18, plus 6 is 24. The 2 negative charge means that you have to add 2 more electrons. There's 2 extra valence electrons. So we have 26 electrons over here. And we're going to keep track of that. Right there. So just remember, like we did, for every negative charge that you have in the compound, you have to add 1 extra valence electron. For every positive charge, if you had positive charges, you'd subtract 1 valence electron for each positive charge. Okay. The next step is to arrange the atoms. A few things, rules of thumb, not hard, fast rules, but rules of thumb. Well, this one is. Usually it works out best to put the least electronegative element in the center. The compounds we're starting with, they're going to be pretty simple. It's going to be 1 element in the center and the other atoms arranged around it. And we'll branch out from there. But this is always true. Hydrogen's never going to be central. It only comes with 1 valence electron. It can only form 1 bond, so it can't be central by forming only 1 bond. Well, when we look at selenium and oxygen, selenium is further down in the same column as oxygen is, so it's less electronegative. So we'll put the selenium in the middle and arrange the oxygen atoms around it any way you want to, pretty much. That's step 2. The next step is to connect all the peripheral atoms to the central atom with single bonds. And when you do that, you're going to subtract 2 valence electrons from the total that we counted originally for each of the bonds. So I'll just draw a straight line. Yeah, more or less straight. So each line is 2 electrons, 2, 4, 6. Subtract them. We have 20 left. The next step 4, is to satisfy the octet rule for all the peripheral atoms using the remaining valence electrons we have up here. If we have any left over, they go on the central atom. So, as drawn in this structure here, each oxygen is only seeing 2 valence electrons, the line. And the octet rule says oxygen needs 8. So each oxygen needs 6 more. 6 times 3 is 18. We have 20, so we have enough to do that. So we'll put 2 dots for each lone pair for each of the oxygens. Subtract them, we have to keep track. We have 2 valence electrons left. We have them left over, so no matter what, stick them on the central atom. Put them right there. Step 5 is to check the octet rule for all of the atoms in your structure. And if any of the atoms don't have the octet rule satisfied, then do so by making a double or triple bond. By the way, we have already used up these 2 by putting them on the central atom. Here, okay, oxygen sees 2, 4, 6, 8. All of them see 8. Selenium sees 2, 4, 6, 8. The octet rule is satisfied. By the way, if it's an ion, you should put the entire structure in brackets and put the charge in the top right-hand corner of the brackets. The 6th step is to calculate the formal charges on all the atoms in the compound. Keeping in mind that the best structure will have the smallest magnitude formal charges, and if more than one structure satisfies this, then you want to choose a structure that has the negative formal charge on the more electronegative element. Or you might want to say that as the positive formal charge on the less electronegative element. So let's do that. Each oxygen comes with 6 valence electrons. By the way, remember, formal charge is valence electrons minus lines minus dots. So formal charge is the valence electrons for the neutral atom minus the number of lines touching it in the structure minus the dots on it in the structure. So for oxygen, comes with 6 valence electrons minus 1 line minus 6 dots gives this a -1 formal charge. All the oxygens look the same. They'll all have the same formal charge. For selenium, it also comes with 6 valence electrons minus 3 lines minus 2 dots is a +1 formal charge here. Oops. So now we want to see if we can get that any better. They're all, okay, can any be 0? And can we get rid of any of these formal charges? And yeah, we can. If we take one of these lone pairs on any of the oxygens and make a double bond to the selenium from the oxygen. Now, oxygen here has 6 valence electrons minus 2 lines, 4 dots is a 0 formal charge. Selenium, 6 valence electrons, erase those, minus 4 lines and 2 dots is 0. So if it's a 0 formal charge, you don't usually write it. Well, but selenium in this structure has 2, 4, 6, 8, 10 valence electrons. That's okay, because remember, any element in the 3rd row or lower of the periodic table can have an expanded octet. Selenium's in the 3rd row or lower, it can have an expanded octet. This is the best structure we're going to draw. We could have put this double bond here or here and it wouldn't matter. That's another topic. That's called resonance forms. We'll do that later. There's the structure for the selenite polyatomic ion.